So, in the previous classes, we have seen how to generate the Mac functions. Already, we have seen how it could be generated as Mac functions here. Today, we'd like to concentrate on Hmac, hash message authentication code. Difference between Hmac and Mac is in Mac, we never use any key. For applying for encryption, encryption in the sense you want to make sure that your data could also not visible to anybody, then you have to take some encryption and decryption algorithm for by using some key as far as Mac is concerned. But for preparing message authentication code, you never ever use any kind of key over there. If you consider SHA algorithm, there is no key for SHA. Okay, only plain text will be there. Taking plain text and you have to follow 80 rounds, and 80 rounds will be after 80th round, it could be generated some 160 bits key. Sorry, 160 bits output. That output is message authentication code. Okay, so in all other kind of algorithms, so key will be scheduled, whereas in SHA algorithm, the message will be get scheduled. So that is the difference between so all algorithms and message authentication key codes. So here hash message authentication code in the sense. So here we have to use a key. So message authentication code MAC. So with a key, with a particular key will be called as Hmac. So that is the basic difference between MAC and HMAC. Okay, that is the basic difference. Let us come across this one. What are the design objectives? Why Hmac was created here? Number one, so these hash functions will be made available for anybody freely. Okay, so if you give hash function to the people, and sometimes there might be having some kind of problems to access the code also. If you consider your routers, so number of routers are there for Wi-Fi routers will be there. If Wi-Fi router could not be applied with any key, if it is open in the sense, many people will connect, and your internet will be, bandwidth of your internet will be shared by many people. Okay, to make such kind of feasibilities, then Hmac is supposed to be used. So key will be migrated with the Mac. So that is the specific operation where exactly we required this particular Hmac. And then second point is so replaceability. If anybody wants to change the key, yes, you can change. If anybody wants to, anybody in the sense, the person who is a genuine party will be make that particular key, so will be changed in the sense it could be. So then such kind of embedding of reliability of your key will be there, then Hmac can be used over there. And third one is to preserve the original performance of the hash function. So if a hash function, hash value will be there with you, then that hash value will be the map towards your actual bandwidth of your Wi-Fi router. Actually, the service provider will be do this particular operation only. A MAC value will be generated for your line, and that could be so bind together with your IP address. You could not give any IP address over there. So in ISP, so people would not be give any ISP over there. MAC will be created. Your MAC and IP address what he wanted to allocate to you, both will be so tied up together, and that will be generated to you with username and password. So such kind of preservation of original performance of your line or your hash function, then you may be use this particular Hmac over there. And then to use and handle keys in simpler way, very much simpler way. Okay, already I told you how the things will be. So for these reasons, so why Hmac is being initiated here. Hmac can be initiated or invented here. And authentication, cryptanalysis and authentication mechanism also be embedded towards the MAC message authentication codes. For this reason also Hmac was introduced. So here Hmac is also considered as a black box. Black box in the sense this black box cannot be opened by anybody. it could be opened by the person who is authenticated. Only that particular person can be open that black box only. And if you consider aircrafts or aeroplanes or choppers, helicopters, if you consider all those things, in cockpit black box will be put safely. If anything is being happening within that particular aircraft, everything will be recorded by that black box. Black box could not be opened by all people, so that could be opened by the persons who are very much authenticated, something like that. So HMAC is used as a black box kind of operation in terms of the security. And an existing implementation of hash function can be used. So existing implementation in the sense, either it is SHA, so secured hashing algorithm 1 or secured hashing algorithm 2 or secured hashing algorithm 512. 512 is the latest one actually. So either of these can be used to implement the HMAC. Okay, HMAC can be used to implement either of existing hash functions. Okay, MD5 or SHA1, SHA2, SHA512, SHA256, whoever, you can use any one of them. By using them, so you have to prepare this HMAC thing here. Then how this could be looks like. The algorithm can be looks like in such a way. Algorithm can be seen in such a way. So you have to take k plus. So let me explain what are these points here. So k in the sense the secret key. So it is a secret key, and the secret key will be, so normally this whole HMAC keys, it depends upon one particular point. The point is, so let me consider B bits are supposed to be taken into consideration. Normally B bits in the sense, this B bits might be, so 512 bits, 512 bits. Okay, so whatever the so key, you have to consider the key must be in terms of 512 bits here, and these 512 bits must be taken into consideration while you take any kind of input here. For example, if your key will be let me say some 312 bits have been taken by you. For example, 312 bits will be taken by this secret key. So you have generated such kind of key with you. Then you must make this 312 bits to, so 512 bits on appending of zeros at left hand side of the key. For example, this will be the key. For example, let us consider this will be the key which was considered or taken by me. This is the key here. So this key size will be 312 bits. For example, 312 bits, and actually your number of bits which is being taken by your HMAC is 512. So 200 more bits are required here. So to make your total secret key into 512, so you have to append zeros at the back side or left side, most significant bit side. Why you have to make the this many number of zeros at only most significant bit in the sense? For example, decimal value 2 will be equal to, so 10 actually. If you put zeros at left hand side, that is most significant bit side, 0, 0, 0, 0, 1, 0 will be always equal to 2. Similarly, if you place so the bits, 0 bits at right side, least significant bit side. So 1 0, for example, if you put one more 0, it will becomes 4. If you put one more 0, 0, 0, 0, it becomes 8. So value of your 2 will be gets changed if you put the data, zeros towards least significant bit side. So that is why append number of zeros until how many number of zeros will be required to make your key to B bits. So you have to append those many number of zeros at the most significant bit side. Okay. So if you take a key, secret key as key K, if number of bits in K will be less than B bits, then you have to append the zeros. After appending, whatever the output you have to get, that key will be called as K plus. That key will be called as K plus. I hope that you understand what I spoke to you. So for simplicity, I would like to specify one example here. Let us take a small example here. You require so 20 bits of key actually. So you require actually for doing this particular whole business 20 bits is required. But you have form one particular key. That key will be some 16 bits. Okay, exclusive OR operation will be always required. So both operands must be in same length. Number of bits of first operand will be always equal to number of bits which are available in the second kind of thing also. So therefore you have generated one key with 16 bits. Okay, so which is the B size will be actually 20 bits, but you have generated 16 bits. So that you need to add 4 more bits. So that way that will be called as K plus here. K plus might be so equal to so 0 0 0 0 4 zeros plus whatever the 16 bits you have there, you have to append them. You have to append them. So append them, finally it could be becomes your new key. So since this new key does always have B number of bits. Normally B will be equal to 512. So that is the standard block size of your B here. So that could be taken into consideration, first one. Secondly, so you need to consider iPad and OPAD. So let me go ahead and take this particular thing. Not exactly here. What are the iPad value and the OPAD value here? So this is the iPad value. 36 in hexadecimal. 0011 01110. That is this is 3 and this is 6 here. 36 in hexadecimal, and OPAD is 5C. So 0101 and 1100. So this is 5C in hexadecimal. These bits will be OPAD will be, so for example it could be B value will be equal to 512. So how many bits are there in OPAD as per 36? 8 bits. So you have to append 36 continuously for several number of times until total number of bits within that particular thing will be satisfied. So 512. Okay, how many times you are supposed to append towards that one here in the sense? Let me take a calculator. So 512 divided by 8. So totally 64 times. So these number of bits are going to be written continuously. So therefore that would be considered as 512 bits. Okay. So 36 in hexadecimal, 5C in hexadecimal. OPAD will be equal to 36 and OPAD will be equal to 5C. iPad will be equal to 36 and OPAD will be equal to 5C. So like that you have to consider, and whatever the key you have generated by on appending of zeros, so those two will be exclusive OR. After exclusive OR, so whatever the output, this output could also be B bits. This output also be B bits. So therefore whatever the output of this exclusive OR that has been appended to actual plain text. So from here to here, this is plain text. Okay, plain text might be any length, whatever the length it might be, any number of bits it could be taken into consideration. That doesn't matter here. So for this plain text, whatever the output of K plus iPad will be appended to this particular thing here. Then after getting this whole thing will be as a plain text, then apply hash function. This hash function could be taken 2 inputs. One is so SI, whatever the K plus and iPad exclusive bit plus your plain text will be take one particular input. Second input is so initial vector. Obviously, so SHA will be taken some initial vector. That initial vector might be having n bits. Okay. So B bits and n bits will be taken into apply into so this hash function. It could be provide so n bits of output here. After getting n bits of output, so the SHA output will be n bits here, and this will be again padded with one more. Already we have padded with iPad with K plus. Now here right now, so OPAD with so iPad in the sense 36 in hexadecimal, OPAD in the sense 5C in hexadecimal. 64 times 5C will be continuously appended, will be called as OPAD, and that will be exclusive OR with K plus, and could be appended with the hash value of so the first previous one here. And again, you have to apply hash 512 one more time, SHA 512 one more time with initial vector. Okay, then you maybe get some kind of output. That output is called as Hmac. So look at this. You have used so key in twice. So in this particular whole algorithm. Okay. So in this whole algorithm, so we have used this key for twice. Twice we have been used here. Okay. And the consideration of iPad and OPAD also very, very important. So iPad will be always 36 in hexadecimal for 64 times. OPAD will be 5 in hexadecimal for 64 times. Okay. If you perform if you append for 64 times continuously, then that will becomes 512 bits. That is the actual length of B bits here, so that you can perform the operation. Okay, so that is what we have explained here. H is embedded hash function. Embedded hash function in the sense this particular function that is SHA SHA normally SHA 512 can be gets operated here. 512 can be gets operated, that is the H value. IV, initial vector for SHA, initial vector for SHA. Then followed by M will be message authentication code. So whatever the message authentication code you have been operated, so to operate that one, so that particular M will be actual main text message. And then followed by Y will be so number of blocks. Each block size will be so B bits. So B bits in the sense of 512 bits here, 512 bits here. And L will be a number of blocks which has been divided into the M. M will be total message. The message will be divided into so several number of blocks. How many number of blocks in the sense? L number of blocks here. And then followed by B will be size of each block. And then N will be length of hash code which is being produced by the SHA. And then K will be the secret key where exactly you have been considered. Okay, K plus will be formed if K will not be equal to 512, let me say B bits, then you have to append zeros towards most significant bit side. Okay, so this is what happened. So that is what we have given here. So these are the things which we have to consider in terms of Hmac here. So iPad will be prepared by using this one, and OPAD will be prepared by using this one for number of times, which will be satisfied B by 8 times. After this, the Hmac can be operated something like this. Hmac will be equal to Hmac of K comma M will be equal to hashing of K plus OPAD appended with hashing of K plus iPad appended with message. Okay, hashing. So you could get some particular value here. That value could be appended with another iPad value and appended with message. If you operate twice for this particular hashing, then that could be called as Hmac. So that is the actual operation. Okay. And algorithm. So I have written algorithm. This is actually a textbook algorithm, but I have written in simple words. Look at this. So you have to select a secret key K of length of K bits, and K must be always satisfies 0 less than or equal to K less than or equal to less than or equal to B bits. If K will be number of bits in K will be less than B bits, then append zeros. So append zeros to the left side, that is most significant bit side, so that the K will be make B bits. Okay, which is called as K plus. Then followed by exclusive or K plus with the iPad. iPad in the sense 36, hexadecimal value 36. So that it will be gets B bits again, and the actual operation will be S1 will be equal to K plus exclusive or iPad. And this will be appended to the actual message, which is divided into several number of blocks. Each block size will be B bits. Okay, S1 is appended to actual message. After appending, you have to operate on this whole particular text. On this whole particular text, you have to apply SHA-512. Okay, SHA-512 will be gets operated. Then by taking the second input as IV, initial vector, so you have to apply the SHA-512 on this particular whole text, which will be gives you n bits as output. N bits will be output will be given. Then you have to append so a number of bits to make that particular SHA output as B bits. SHA output will be always 160 bits only. Otherwise, so 228 bits only. So if you want to make this one 228 to 512, you have to append number of zeros until it will be becomes 512. After getting that one, again exclusive OR could be operated with OPAD. OPAD value is 5C, 5C, hexadecimal 5C for 64 times. Then you could get S naught. S naught will be K plus exclusive OR of IPAD. Uh, I write a mistake here. So this is OPAD. Sorry, this is OPAD, not iPad. This is OPAD. Okay. Then after that, so again on this particular data, again, so SHA 512 one more time with the initial vector. Then you could get some output. That output is called as Hmac. Totally, we do have 7 steps. Okay, totally we do have 7 steps. In this way, Hmac is being generated. This Hmac is very much useful for us. So Hmac will be always gives you a facility to put one particular password on that Mac address. So that password must be always equal to 512 bits. If you are unable to provide 512 bits as far as the password requirements, Hmac will be internally appended a number of zeros towards most significant bit side. So therefore, so it could be worked out in such a fashion. Okay, this is what about Hmac, and I will forward this document to you. Okay, please go ahead. Still only 6 people.